All right, yesterday in science, you guys just basically kind of investigated what magnets can do, okay? When you were just playing with the magnet and the paper clip, somebody told me something that you saw that it was able to do. What did you notice? What could you get it to do, Bethany?
When I dropped, at the right angle, if I dropped the paper clip and the magnet at the same time, then it would like.
Okay, if they were both just kind of bouncing near each other, they kind of jump together. Okay, what'd you do, Zoe?
It stuck to the balloon.
To the what?
The balloon.
When you played with the magnet and the paper clip.
I thought you guys meant.
Nope, you don't have to think, you can just listen. That's the beauty of listening. What was something you did or you noticed? What did you see, do or notice with it?
I put the paper clip on my desk
Uh-huh.
and the magnet, and it did this, and it went all the way around my desk without connecting.
Okay, she was able to get it to follow the magnet around her desk without it actually touching and hitting the magnet. Okay, that was probably pretty tricky to do.
It was.
Okay, because when you get to a certain point, it just kind of goes, whoosh, right? Brody, what'd you do?
So I basically put my paper clip on top of my desk with the magnet underneath. If I moved the magnet, the paper clip moved through my desk.
Okay, so you kind of did something like this, where you had the paper clip on top. Let me use the other side. And the magnet on the back. Okay, and then you moved it around like that.
Whoa.
Oop.
Whoa. But it didn't go.
I must have moved too fast. All right. Calvin, you did something similar to that. What'd you do?
I had my eraser,
Mm-hmm.
and I put the magnet on the bottom and the paper clip on the top.
Okay. And it stayed there, right? All right, all the way through the eraser.
That's a big
Okay. What'd you do?
I just set it there and made it hover above it, and then it flew up.
Okay, so you were there until all of a sudden it just jumped way up to it. Depends on the magnet too. This magnet may not be super strong. All right, so he was just kind of holding it and then waited until it went boop, and just jumped up. Okay, what'd you do?
I put the paper clip on my desk, and I held the magnet on top of it. Well, not really, but
Above it.
yeah. And then I got it to spin around in circles and move around while it's spinning around.
Okay, who else got it to spin in circles? Who tried and it just didn't work out for you? Okay, it might have been more the paper clip, because you might have had a paper clip that was bent down just a little bit so it had something to spin on. Whereas if you had one that's totally flat, it might not have worked very well. Okay, so it wasn't you necessarily, it probably was your paper clip. Yes?
I also did, I put the magnet on top of this part of my finger, and I put the paper clip on the other side, and it stick together.
Really? You might have too thick of fingers. Oh, it kind of wanted to work.
It took me a while.
Okay. What'd you do?
I took two magnets and one of those. I put it in the middle, and it just didn't go anywhere. It's like
Okay.
whenever I pushed it, it would fall out, but if you put it right in place, it would just go
Okay.
in there.
You're only supposed to have one magnet. All right. That's okay. Here's one other thing that happens with magnets. That's kind of incredible. If I take these two magnets, right now, they don't want to go together. Okay?
Yeah, I'm not doing that.
Because I have I don't have the opposite ends. I have the same ends forcing them together. Do you know what those are called?
The north and south edge.
Yes, they have like a north pole and a south pole. You know how on the Earth we have a north and a south pole that's the opposites? Okay, same thing with magnets. Okay? They have sides that are opposite of each other. And if I take the north and the north of two net magnets, and I'm sorry. Okay, if I take the north and the south of two magnets and put them together, they want to go together. Okay? But if I put the north and the north, I have to kind of force them together. And if I let go, it jumps off because it does not want to be with the other one. Okay? I have to force it down really hard to get it to even be there, and I'm pinching really hard. And if I let go of the top part pinch, it just jumps in the air. Okay? The reason we did this is because we're going to be talking about forces and motion. Magnets are very unique. Somebody tell me, what would you normally have to do to get something to move? Normally, don't think of magnets. Normally, what would you have to do to get something to move? Like if I told Avery to move her chair, what would she have to do to be able to move her chair?
Push it.
Yeah, she'd have to touch it to push it, or touch it to pick it up, or touch it to drag it behind her, but she's touching it. Magnets are very unique because do magnets have to touch things to move them?
No.
They don't. They can cause motion without actually touching it. I always think of Star Wars and the Force when I think of magnets because they're kind of moving things without doing anything. All right? Okay? Yes?
Another thing about the oath and nothing so cool, technically the oath is a different magnet.
It is. It has a magnetic field on it. Okay? And so it does have a magnetic thing going on. It's not like metal's going to stick to it, right? But it does have a magnetic field that's part of why a compass works. Okay?
Without the magnetic field.
Correct.
With gravity, the Earth is kind of like a giant magnet to us because everything sticks to it. Like it doesn't like.
It's like it, but that's not why we are. It's not magnetic forces that hold us on. It's gravity that holds us. Okay, we'll worry about gravity later on. All right, gravity's kind of a weird thing. All right, even though we rely on it every day. Yes.
So, if the world's spinning at why do we have a magnetic field?
On the Earth?
Yeah.
Because God made it and it has a magnetic field. I don't know. You'll have to ask him. I don't know why he did that. I don't know. Okay. Then the second thing we did was we went around the classroom because magnets don't work on everything, do they? Let's kind of make a list of things that worked with the magnet, things that did not. Oops, hang on, I got a recording and I need to use a black marker because I don't think you can even see the green one.
It's blurry.
Okay, worked. Did not. Okay, what's one thing where the magnet worked?
On Colton's water bottle.
On Colton's water bottle. Okay. Did anybody else try a water bottle? Did anybody else's water bottle work? Raise your hand if your water bottle also worked. Okay.
I had a different.
You had a different water bottle. All right. So, water bottle. Oops, a boodle. What was true? Somebody tell me something about all the water bottles that worked that was different from the ones that did not work. How are they different?
They had metal on them.
And what were the other ones?
Plastic.
Okay, so the ones that worked were not plastic. They were metal. So we're going to have to come back to that idea in a little bit. Okay? Who else had something that worked? What else in the room worked?
Your guitar.
What part of my guitar?
This and this and this.
Okay? So my guitar stand, the strings, like this part? Or this part? Okay, the strings and the tuners. So my guitar strings, my guitar stand, and the tuners, if you're looking at them, what are all those things made of?
Metal.
They're actually made of metal, aren't they? I'll put various guitar things.
So much metal.
And they were all metal. Give me another thing that worked. Go ahead.
Metal
That's not a thing. Yes?
Another thing that worked were the bottom of our chairs.
Okay, the bottom part, the legs of your chair. Yup. And that also? Metal, wasn't it? Chair legs. Metal.
Interesting. All things.
Brody, what'd you try?
That red stapler.
Did it work? Okay, is there metal on that?
Yes.
Okay, did it work on all parts of the stapler? For the most part? Or did you just do it on one part?
All per.
Okay. I think most staplers are pretty much stapler. Also, that's metal. I think we've got something kind of going on that's going to be the same. Olivia, what'd you try?
Well, that basket over there was the tissue box.
Okay, and did it work?
Yeah.
Okay, this thing that I don't have on my desk anymore. Yeah, it works there. Is that metal, Olivia?
Yeah.
Yeah, that's metal too. Alright, so paper holder. And it was metal. Okay, give me something that did not work. Give me something that did not work. You tried it? Nope, didn't do it.
I tried to stick it to my.
Okay, our offices didn't stick to those. Does it have metal?
No.
I don't think so. It seems like plastic to me. What else didn't work?
This little thing.
Oh, this thing right here she says doesn't work. Who says that's metal? That does not work. So the tray doesn't work, but that is metal. Interesting. What else didn't work?
Can I tell you one and why it didn't?
You can tell me one that didn't work, and then we'll go back to that.
The walls.
Okay, the wall did not work. Our walls in most of this classroom. Yeah, most of them. I guess that wall is not. They are cinder blocks. Except for the back wall is not cinder block. So it does not work on cinder blocks. Give me one more thing that didn't work. Lily.
Like that 3 puncher for the paper. Yeah.
Okay. Well, it's like it wants to, but it really doesn't want to do it on this part. It wants to get underneath somewhere.
Yeah.
What do you think this top part's made of?
Plastic.
That's just, yeah. It's plastic. But do you think the cubby part inside is metal?
Yeah.
I bet it is. So it kind of like, there's metal in there, and it kind of wants to, when it slid down, it kind of went, whoop, and it went underneath. Because there is metal in there eventually. Somebody tell me if you know, why did this metal tray not work? Why didn't that metal tray work with a magnet? It's metal. And we put down metal for all these things that worked. So I thought we were really on to something, and then all of a sudden, Courtney ruined everything. Because she said this tray and it's metal, and no. Why is it? Go ahead, Fletcher, I'll let you say why you think.
Because certain types of metal don't work.
Okay, in fact, I would even change it to certain kinds of metal do actually work. Okay? So, for example, if I were to take a regular penny you who don't know anything? Just raise your hand. This is why we raise our hands. This is a regular penny. Does anybody know what a penny is made of? It's made of metal, but what kind of metal is it made of? And it's the color of the metal. That's what it has the name. What is it, Liam? Okay,
Copper.
it's made of copper, but pennies nowadays are made of copper and other metals. Because here's the thing. Copper is expensive enough that if you took like $1 worth of pennies, if they were really made of copper and melted them down, you could sell it for like $3. So that's why they don't make it out of copper anymore. In fact, a lot of people think that in a few years we probably won't even have pennies anymore.
Yeah.
Because there's nothing you buy really with just a penny.
Yeah.
And so we might just get rid of them because it'll be easier. Okay? So, if you want to keep a few pennies just in case they get rid of them all. All right. So this is made of copper, and copper doesn't work. Neither do the other metals they use now. And I think there's like zinc is one of them because it's a very inexpensive metal that's inside of here. So none of those work. Okay? This is probably made out of aluminum, like an aluminum can. It doesn't work on aluminum either. Okay? A metal has to have iron in it. That's the metal that's actually attracted to this. Okay? So steel is a type of metal that's made of a couple metals. Iron is one of them. Okay? And so it has iron in it. So anything that this sticks to has iron in it. How many of you are wondering, well, what about this? Is this even metal?
No.
Yeah, this isn't metal. Somebody tell me what must be true. Because what I'm writing on is definitely not metal. What do you think is true, Colton?
I think there's like metal in it.
Okay, behind this layer, they put metal because they know that teachers and other people that use these things sometimes like to be able to magnetically attach stuff. Okay? So they put a thin coating of something that has iron in it so that magnets can stick. It's more useful. Okay? Yes?
What are magnets made out of?
Well, that's a tough question. They are also, that's a good question. I'm going to have to look that up. I want to say they're also made of iron, but that's not going to be right. I'll look into that. Yes, do you know?
I could ask Alexa.
You could. I was just going to ask Google here, so. But not right now because we need to get going. Yes?
I think maybe some part of the magnet is made of copper. No, not copper. What's the type of metal that sticks to again?
Iron.
Iron. I think maybe the south side is.
Well, I don't